Hey everybody, Bob Hope here. And this calculus lesson is divided up into three parts. It's on Extrema application problems, and we're going to optimize. So some word problems here. So I have several examples, but I'm doing three different lessons on this. So here we go. So in these word problems, you guys, your goal is to get one variable and to solve for critical. So if it asks you to find a minimum and you get a maximum, then you're done. You just say there is none right there. So always test with a number line. Once you get your criticals, once you do the derivative, and then use a number line to test, uh, always show the number line. So if you're doing the AP exam, or your teacher wants to see that also, and show that it is a max or a min. Okay, so in most cases, if it asks for a max, then the answer is going to be a max, and if it asks for a min, the answer will be a min. But sometimes they'll try and trick you. All right, so procedure, you guys. Let's go. You go ahead and draw a picture, label parts, look for, and then watch out for any domain issues, you guys. So if you get an answer that's outside your domain, then toss that out. And I have an example of that in here. And then what is it? Is it a max or a min? And so write an equation in one variable, and then take the derivative and solve for the criticals, and which means set it equal to 0. Your derivative equals 0. Make a number line and test for criticals to make sure it's a max or a min, and then answer the question completely. So okay, so don't stop when you just solve for x. Okay, so always make a number line and answer it if it's a max or a min, and then just answer the question. Here's one. Find two positive numbers such that their product is 192 and the sum of the first number plus 3 times the second is a minimum. Okay, so here's two equations. There's the product, that's 192, and the sum is the first number plus 3 times the second. Okay? Alright, so what we're going to do is we're going to be asked to minimize this. So it's asking that the sum is a minimum. So what I have to do is get one variable. So I think I took this equation and I solved for y. So I divided both sides by x. Okay, there it is right there. And then I'm going to substitute that in. And I get the sum equals this right here. Okay, now this is 576x to the negative 1. So when I derive this, you guys, I get 1 minus 576x to the negative 2. You guys okay with that? Set it equal to 0. And then cross multiply. X squared equals 576, so you get plus or minus 24. Okay, now it said positive number, so I can disregard the minus 24, so it's only positive, so x equals 24. Make a number line and test. Always test with your s prime, so I'm going to test it right here. 1 minus 576 over x squared. So test a number on the left of 24 and a number on the right, and then make sure it does answer the question. So it is a minimum right there. Most of the time it is what it's asking, but sometimes it's not, you guys. All right, and then don't forget it says find two numbers. So if one number is 24, then 192 divided by 24 gets me 8. Okay, easy enough, right? All right, they're not all that easy. Okay, here's another one. Find the point or points on the graph of y equals 4 minus x squared closest to 0, 2. Okay, so a picture. This is a parabola, you guys. It's going down. Okay, it's basically a distance problem right there. Okay, here's 0, 2 right there, and then here's the y equals 4 minus x squared, this upside down parabola. Okay, all right, so we're looking for, there's two distances right there. We're looking for those guys right there. Okay, so there's distance formula. Remember that from your Algebra 1 class? Let's see, and then so we're looking for the distance between x and y and 0 and 2, so we plug it in right there, and then don't forget that y equals 4 minus x squared, so I substituted in 4 minus x squared for that y right there. Clean this up. 4 minus 2 is 2 minus x squared. Going to FOIL that out and clean it up with the x squared right there before I take the derivative. So there it is, FOILed out. There it is, cleaned up. Okay, and I just have it on the next page right here. Little u substitution. I let u be the inside stuff right there. So then this becomes d equals u to the 1/2. So when I derive this, you guys, here's the derivative of u right here. So I just derived this right here. And then so the derivative of your distance formula then is going to be, since it's u to the 1/2, it's going to be 1 over, or it's going to be 1/2 u to the negative 1/2, which is 1 over 2u to the 1/2. Okay, times du. Okay, and then du is the 4x cubed minus 6x. So there it is over there. Okay, so that's my derivative right there. So now to get my criticals, I set the top equal to 0 and the bottom equal to 0. All right, so when I set the top equal to 0, I get x equals 0 right here, and x equals plus or minus 3 halves, the square root, sorry. And then this one doesn't factor to get me, so this one never equals 0, you guys. There's no factors of 4 that adds to negative 3. There's factors of negative 4 that add to negative 3, but not positive 4. All right, so I'm going to use a number line and test with these criticals, 0 and then plus or minus root 3 over 2. All right, so when I tested that into my derivative right here, and I'm just saving that time, plugging them in. You guys have calculators, you can plug them in. And I get negative, positive. So that tells me that it's going down and it's going back up. So that means this is a min. This is going up and it's going back down. So that's a max. This is going down, so it's going back up. So that's another minimum right there, okay? And the problem is asking for minimums right there. So the minimum distance, don't forget you just plug in root 3 over 2 and negative root 3 over 2 in for right there and solve for y, and I get 5/2. Okay, so there's the 2 points right there that gives me minimum distance. All right, let's try one more, you guys. Okay, so construct an open box with a rectangular base from a 16 by 21 inch piece of cardboard by cutting out squares in each corner and bending up the sides. Find the size of the square that'll give us maximum volume. Okay, so here's a picture right there. Okay, so my cardboard is 16 by 21. Okay, and I'm going to cut out a little square, an x by x square on each corner right there. All right, so if this is x and this is x and this whole length is 21, then this region right here is 21 minus the 2x right there. That's what this is. Similarly, this little piece is 16 minus 2x. All right, and then I'm going to fold it up and get that picture right there. You guys with me? Okay, volume, base times or length times width times height right there. So I'm going to multiply all those out to get volume right there, FOIL all that mess out. Okay, and then I get that, so I pulled a 2 out of that. It's just easier to derive this guy with the smaller numbers right there. So when I take the derivative, I get that, and then I pulled another 2 out of these guys, so that's where the 4 came right there. I just divided out another 2, and then I can set this equal to 0. Okay, and I have this on the next page over here. All right, so that factors. Took me a little bit to get that to factor, but it does factor right there. So then I set these equal to 0, and I get x equals 28 thirds, or x equals 3. Okay, now 28 thirds, you guys, is 20. Let's see, 3 goes into 28 9 times, so that's 9 1/3. Well, that's too big, you guys. So anything that's over 8, there's no box, so I can disregard that. So there's a domain issue right there. Okay, so my critical is just x equals 3. So test it on the number line, and I find out that's maximum. That's what we wanted, a maximum volume. So we're going to cut out a little 3 by 3 square. All right, if you're in my calculus class, I would assign that for your homework. Take care.